Assalamu alaikum students. We are going to do a short revision on empirical and molecular formula for the A students for unit 1. Bismillahirrahmanirrahim. We have an organic compound which contains carbon 66.7% by mass, hydrogen 11.1%, and oxygen is 22.2% by mass. So having known the masses of carbon, hydrogen, and oxygen, we have to find the number of moles of each of the elements. Number of moles is equal to mass divided by relative atomic mass of that particular element. To find the number of moles of carbon, divide the mass of carbon by the atomic mass of carbon. Similarly, mass of hydrogen by the atomic mass of hydrogen. Mass of oxygen divided by the atomic mass of oxygen gives you the respective number of moles. So knowing the moles of carbon, hydrogen and oxygen, to convert it into a simple ratio, you divide each one of them by the smallest of the three. Smallest of the three is 1.39, so 5.56 divided by 1.39, 11.1 divided by 1.39, 1.39 divided by 1.39. The ratio comes to 4 is to 8 is to 1. Therefore, the empirical formula is C4H8O. Now, molecular formula is equal to empirical formula times N. What is N? N is equal to relative molecular mass divided by empirical formula mass. We know that the relative molecular mass is 72 and the empirical formula mass is found from the empirical formula C4H8O. We have 4 atoms of carbon that you multiply by the atomic mass of carbon. We have 8 atoms of hydrogen multiplied by the atomic mass of hydrogen. We have 1 atom of oxygen multiplied by the atomic mass of oxygen. So when you add them up, it comes to 72. Substitute that value in this denominator. We get 72 divided by 72 equals 1. Substitute the value of N in over here. Therefore, the molecular formula comes to C4H8O. In this particular sum, 1.24 grams of phosphorus was burned completely in oxygen to give 2.84 grams of phosphorus oxide. So from this we can calculate the mass of oxygen, which is equal to 2.84 minus 1.24 equal to 1.6. Knowing the mass of phosphorus and knowing the mass of oxygen, we can calculate the number of moles of each of the elements. Number of moles is equal to mass divided by relative atomic mass, which is equal to 1.24 divided by 31 and 1.6 divided by 16, which is equal to 0.04 here and zero point 0.1. So from this, among the two numbers, 0.04 is the smallest, so divide both of them by 0.04 to get the simple ratio. We get 1 and 2.5. Then to convert it into a whole number, multiply both of them by 2. For phosphorus, we get 2. For oxygen is 5. And therefore, the empirical formula is P2O5. Molecular formula is equal to empirical formula times N, where N is equal to relative molecular mass divided by empirical formula mass. Relative molecular mass is 284 given in the question. We have to calculate the empirical formula mass from the empirical formula P2O5. We have 2 atoms of phosphorus that should be multiplied by its relative atomic mass. We have 5 atoms of oxygen which has to be multiplied by relative atomic mass. So the answer comes out to be 142 when you add. So N is equal to relative molecular mass divided by empirical formula mass, which we just calculated, that is 284 divided by 142 equal to 2. Substitute the value of N over here. Therefore P2O5 times N. So times N bracket means multiplied by. Therefore phosphorus is 2 2s are 4 and oxygen is 2 5s are 10. Stop. In this particular sum, 3.22 grams of sodium sulfate crystals were gently heated. When all the water of crystallization had been driven off, the mass of sodium sulfate was 1.42 grams. Knowing the mass of the hydrated crystals and the mass of the anhydrous sodium sulfate, we can find the mass of water. Knowing the mass of water and the mass of anhydrous salt, we can just put the headings Na2SO4 and H2O. So find the number of moles of sodium sulfate, which is equal to its mass divided by relative molecular mass. Similarly, find the number of moles of water, which is equal to mass divided by its relative molecular mass. It amounts to 0.01 for sodium sulfate and zero point 0.1 for water. Now, to get the simple ratio, divide both of them by the smallest. When you divide both of them by the smallest, for sodium sulfate you get 1 and for water you get 10. Therefore, the formula will be Na2SO4.10H2O, where 10 is the value of X. In this particular sum, 1.87 grams sample of an organic compound was burnt completely to form 2.6 grams of carbon dioxide and 1.63 grams of water. So here we are supposed to calculate the empirical formula of the sample. To calculate the empirical formula, we need to know the mass of carbon, we need to know the mass of oxygen, and we need to know the mass of hydrogen. That can be calculated only from this particular data. So mass of carbon in carbon dioxide is equal to number of moles of carbon dioxide into atomic mass of carbon. Mass of carbon dioxide is given as 2.65 grams and its relative molecular mass is 44. So from this we can calculate the number of moles. Atomic mass of carbon is 12, which amounts to 0.723 grams. Similarly, mass of hydrogen in water is equal to number of moles of water into atomic mass of hydrogen into number of hydrogen atoms in water. Number of moles of water is equal to mass of water divided by relative molecular mass, which is 1.63 divided by 18 into atomic mass is 1. Number of hydrogen atoms in water is 2, which amounts to 0.181 grams. So knowing the mass of carbon, knowing the mass of hydrogen, we can calculate the mass of oxygen. Mass of oxygen is equal to 1.87 minus the sum of these two elements, which is equal to 0.966. So knowing the mass of carbon, knowing the mass of hydrogen, and knowing the mass of oxygen, we have to calculate the number of moles, then the simple ratio. After calculating the simple ratio, the empirical formula comes to CH3O.